going to transform this table into this. Okay, so let's start doing our normal forms. I have an example here with a sporting goods company that sells baseball, basketball, and golf equipment. This table here is a customer order table, and the first thing I want to start with though is some small examples where I've broken this table down so we can understand the different concepts. So there are 4 normal forms we're going to go over. They each have their own little definitions. The first normal form has a big definition, but really what you need to pay attention to is it has to do with atomic values, and I'll tell you what that is in just a second. Second normal form has to do with composite keys and partial dependence. Third normal form has to do with transitive dependence, and the fourth normal form has to do with multi-value facts. So let's get started. First normal form. So these are little bit pieces of our big table that explain or that show some of the issues that we'll have with first normal form. So example number 1, and we're dealing with atomic values here. So what that means is in example number 1, you have 2 columns. You have a customer column and you have a customer address column. First normal form says you cannot store 2 different things in the same column. So in this case we've got the customer address and we've got the customer email address all in that same column. So that needs to be separated out for first normal form. So let me switch over to the answers, and this first table here, what we've done is we take the customer address and we broke it down into 2 columns. So now the customer address and the email address are in separate columns. This table now satisfies first normal form. So let's take a look at example number 2. In this example, instead of having 2 different things like the physical address and the email address in the same column, we have a multi-value fact in there. So this is customer email subscriptions, and Bob Smith is subscribing to 2 different email letters, one for baseball and one for basketball. And so in order to separate that out, we're going to get more rows. If you look at Bill Smith has 2 different customer email subscriptions, one for golf, one for basketball. So if you look over here, in order to satisfy first normal form, we separate those out into 2 rows. So now Bob Smith has 2 rows, one for basketball, one for baseball. Jill Thomas only had 1 row to begin with, so it's still just 1 row. And Bill Smith now has 2 rows. So now this table satisfies first normal form. So example number 3 is what you're going to find sometimes too. It looks okay because in one column there are no extra values, there's just the one value. But it's kind of a cheat because these 3 columns really make up one concept. So they've taken 3 columns, which is really a group of mail catalogs. So in this case, a mail catalog means they're going to get a physical catalog sent to their physical address. So in this case, Bob Smith will get the basketball catalog, the golf catalog, and the baseball catalog. Bill Smith will get the golf and the baseball catalogs. So to satisfy this one, we have to combine them into one column and add them as rows. And so you can see what we've done here. Bob Smith now has 3 rows, one for each catalog that he's going to get, and Bill Smith has 2, one for each catalog he's going to get. So first normal form has to do with atomic values. Now we move on to second normal form, and it has to do with composite keys and partial dependence. So composite keys, you first have to understand what that means. That means that it takes more than one column to make the uniqueness of the row. So in this case, we have the orders table, and I've simplified it quite a bit. The order needs the customer, the product, and the date to make a unique row. And in this case, Bob Smith ordered 2 things. He ordered a basketball and a bat on the same day. But the key to this, to each record, is going to be the customer, the product, and the order date. So that's called a composite key. Now, partial dependence means the column only depends on one part of the key, but not the whole key. And so in this case, we need to go through the other columns that aren't part of the key and determine what dependence they have. So the first one's customer address. Do you need all three columns to determine the customer address? No. The only thing you need to know the customer address is going to be customer. So the customer address depends just on the customer. It does not depend on the product, and it does not depend on the order date. So that is called partial dependence. So this customer address has partial dependence, and it's not satisfying second normal form. So we've got to fix that. Let's go through the other columns and see what else we have. The product manufacturer. So the product manufacturer, Spalding in this case, does it depend on the customer? No. It depends on the product, yes. So whatever product we have, it has a manufacturer, right? It does not depend on the order date. So the product manufacturer only depends on the product, which is part of the key. So it's partial dependence again. So we got to get rid of that column in order to satisfy second normal form. Now, the final column, quantity. So on each of these order lines, in this case, Bob Smith bought one, but that quantity actually does depend on the full key. So we need to know the customer, the product, and the order date in order to determine the quantity. So the quantity does belong in here. So we don't have to do anything with it to satisfy second normal form. It's in the right spot. So in order to break this out, we're going to end up with multiple tables. And so what I've done here is I've grabbed the customer column and I put it right here. I grabbed the product column, put it here, and I grabbed the order date. So we know those are our primary key, our primary composite key, and then we know quantity still belongs in our table. So it stayed in our main customer order table. But we need to do something with address, and what we did is we pulled customers and their addresses out into their own tables. Well, in this case, I've still got some extra stuff here, so let me delete it as we go. And Mark Smith only needs to be in there once. This will make a lot more sense. Okay, so now we have a customer table whose primary key is customer, the customer name in this case, and their address is only in there once. So the way it was before we satisfied second normal form, if Bob Smith's address changed, we would have had to update it multiple times. We would have had to update it everywhere that he ordered, for every line that he ordered, for every product that he ordered, on every day that he ordered. And so that's a lot of updates for one address. We pulled this address out. When Bob Smith changes his address, it changes in one spot and we're done. We have to update multiple spots, and so you get rid of the update anomalies that you may have. Now, what did we do with product manufacturer? Well, we pulled it out also, and it's got the same issue. I need to get rid of the multiple lines here. There should be one line per product in this table. What we have here is something that satisfies second normal form. So where we have a composite key, the only columns we have in there depend on the whole key. There's no partial dependence. So quantity depends on the whole key. It depends on the customer, product, and order date. And where we had partial dependence, we broke those out into their own tables, and now we have a product table and we have a customer table. And I should also mention that now we have a primary key with a single column on the product and the customer table, and we reference those tables with foreign keys. And I'm going to put a different color for the foreign keys. And so now whenever we want to change a manufacturer name or change a customer address, it's done in one spot, and you don't have to worry about updates and deletes and those types of problems. So that is second normal form, composite keys and partial dependence. Third normal form now is about transitive dependence. So transitive dependence, the dependence is there, and in this case I want to use an example of the product table. So back on over here we had a product table, and I just had two columns, product and product manufacturer. Well, now I went ahead and added the product manufacturer address, the product details, the product cost. So that's all in there. So what we want to look at now for third normal form, we've got a single key. So this is a primary key, the product is. And we need to see if everything directly relates to it. So for third normal form, you have to satisfy first normal form and second normal form. Well, first normal form is satisfied because we don't have any other non-atomic columns. Every column only stores one thing. Second normal form is satisfied because we don't even have a composite key, so everything relates to the key. We're done with that. Composite keys are the only thing that you can have a partial dependence. So since our primary key is the product, we're done with second normal form. So now we got to figure out if this is third normal form. So product manufacturer, if we know the product of basketball, we already know the product manufacturer. Now that can get confusing because you can start thinking, well, different companies manufacture basketballs, but in this example, only look at these 4 rows, ignoring what you do know about business, because we would want to change that in the real world. But for this example, if we know basketball, we know the manufacturer Spalding. And then if we know basketball, we also know the manufacturer address is 1 Spalding Drive. We know the product detail is 29.5 inch, and we know it costs $25. Now, here's where transitive dependence comes in. The manufacturing address really depends on the manufacturer, right? And then the manufacturer depends on the basketball. It's a 2-step process. If we know manufacturer, we also know the address. So that 2 steps is the transitive property that's about third normal form. And where you're going to see the problem and why third normal form's around is if you look at the second and third rows with Rawlings, you can see that we've listed their address twice. Well, now everything that Rawlings manufactures, the way we have our model here, the table, is if we had 50 products manufactured by Rawlings, we would have to update their address 50 times if they made a change in address. Those are the types of things we're trying to get rid of with normalization. So in this case, what we're going to do is we're going to separate the manufacturer out from the product table. And so what I did is I took the manufacturer and their address and I stuck them over here and got rid of the duplicate row. So now Rawlings is in this manufacturer table 1 time. And the primary key, the unique key of this manufacturer table is the manufacturer. Now, in the product table, we no longer have the manufacturer address. We have our primary key, and then we have the product manufacturer, and it relates over here. So if we want to know the address of Rawlings, we would have to join the product table over to the product manufacturer table, and we would have their address of 23 Rawlings Court. The rest of these columns are directly related to product, and so they are just fine in the table, and they already satisfied third normal form. So now this table satisfies third normal form, as does this one. Now we got to get into fourth normal form. So that was transitive dependence. So fourth normal form has to do with multi-value facts. Now in fourth normal form, we've got to be in first normal form, second normal form, third normal form, and then finally fourth normal form. Well, in this case, we look at first normal form, and this column here shows us we're not in first normal form because we've got a non-atomic value there. It's got 2 different values in one column. So what we need to do now is separate that out. But before we do, well, actually let me show that separated. If we separate that out, our primary key changes. So before, our primary key was just the customer, right? Now our primary key, Bob Smith's in there twice because they had basketball and baseball in their email subscriptions. Well, that's a problem, and that happens with multi-value facts. So multi-value facts, in order to get them in there, they're going to add more rows. Well, now the ultimate fix is to separate the tables out. So in this case, we took everything but the subscription and stuck it over here. So these are all the things that are related to the customer, but only have one value. Not multiple values, but just one value. So in this case, there's only one customer address. We don't allow multiple addresses. We don't allow multiple email addresses. So this table that has the primary key of customer is one, only has the attributes that have one thing. Now, when we go over to the new table we have over here, which is like customer email subscriptions, this table is going to list the multi-valued subscriptions. So Bob Smith is in here twice. And so our original table that had the primary key of customer is maintained. And this table over here has the multi-values. And that's how you satisfy fourth normal form. Now, this has a foreign key back to the primary key, but the question I have is, what is the primary key of this table now? Well, let's see, is it customer? It can't be customer because Bob Smith is on 2 rows. Is it email subscriptions? Well, it can't be that because baseball can belong to 2 things. So the primary key of this is the whole thing. So it's both columns together. Let's review. We talked about first normal form, atomic values. Second normal form, which is the composite keys. And you only have to worry about second normal form if you have composite keys, because then you have to look for partial dependence. And in third normal form, you have to look for transitive dependence, where one column doesn't directly depend on the primary key. And then finally, you have the multi-value facts. So that gets through our 4 normal forms. What I want to do is just go through the thought process of how I would normalize this table. So I don't usually think in terms of first normal form, second normal form, third normal form, fourth normal form. I usually think in terms of dependence and the grain of what I'm looking at. So let's start and just walk through this example. So the first thing we need to do is identify what this table, what the key or the primary key is of this table. Well, in this case, the guess is it's going to be the same as the orders table that we did our example on. So we have the customer, we have the product, and then we have the order date. So I'm going to highlight those columns. Now let's make sure that they are primary keys, right? So we've got on customer, we've got Bob Smith, we got Jill Thomas, and we got Bob Smith again. Now the first thing that comes up is that Bob Smith in this case may be a different person, and I think he is. So what we need to do is get some uniqueness on our customer. So what we can do is add a new customer ID, and we'll make a smart key in this case. Okay, so what we want to do is add a customer ID because we want uniqueness here. And so we're just going to do B Smith 1 would be the customer unique ID here. And then we're going to say J Thomas 1. And then we're going to say B Smith 2. Okay, so now our customer has unique ID. Most of the time you're going to just use an identity with a number, an auto incrementing key. But in this case I want to use something that we can actually read. Okay, so no longer is this my key, so I'll clear that one back out. But now this is our key. Okay, so now we've got a unique key for customer. The next question we have, so product, is it unique? Well, this is going to get even more confusing here. Let's look at all the basketballs. So we have a Spalding basketball, and we have a Titleist basketball, which makes no sense, but we do. So we're going to keep it that way. So in this case, basketball by itself is not unique. So we need a key for that product. So we're going to do a product ID key. and we're going to say basketball dash SP for Spalding. And I guess we're going to have to do that for all of them here. So now we have a key, and this is actually our unique key for products, so let's clear that out. Okay, so now we think we've got a uniqueness. So the first thing I'm thinking about here is, well, here's all my unique keys, and I'm thinking more about dependence. So I'm like, so which of these rows only depends, or which of these columns only depend on the customer or the customer ID? Well, we know the customer name, their address, their email subscriptions, their mail catalog subscriptions. All those things only depend on customer, right? So we can break those off immediately. So I'm not thinking in terms of first, second, third, fourth normal forms. I'm thinking of dependence. And I know that my customer ID, I don't need to store all the information about them with the order. So the first thing I want to do is I would grab out all that stuff and I would carve it off into its own table. And then I would no longer need all the customer information there. And now I also have a primary key on this table, which is customer ID. And now over here, it's a foreign key. It's also going to be part of the composite primary key, but it's going to be a foreign key. So now I've already broken down one table. So let's think about the product ID. What things depend on the product ID, right? Well, the product name, the manufacturer address, product details, product cost, all that is directly related to the product ID. So I already have a second table. I'll just grab all those out. I'm going to put them right here and get rid of these columns. And now I have my table, and this just didn't work out very well. The total line amount was a calculation, which is now gone because I took product cost. So that's something you have to think about, right? So in this case, and this is where business rules come in, where in this case we have product cost, and let's just take this first row. The Spalding basketball, the product cost is $25. Well, we're assuming that the product cost doesn't change, so we're not storing that on the order line item. But if the product cost changes, you'll want to store that product cost on the order line item also. But in this case, we're going to leave it out here with the product on the product table itself. So the total line amount we could store here, or we may not store here. And in this case, I'll go ahead and have the calculation stored here. See if I can calculate it up real quick. So we got $25. We got one BAT L, which is $35. We've got, and this is the problem. So if the product cost doesn't change, we're really storing this redundantly, so I'm actually going to remove it, because you can always calculate it with a SQL join just by joining those two tables together. So we're going to get rid of the total line amount. So that leaves us with the order date and the order total. Oh, and product ID is now a foreign key over here. So we'll put that in there. So order date is in here twice. Do we really need order date with the product ID? So what we really have here is like line items of an order. And so there's one more step we can take on this customer orders table, and we can actually call this the customer line order lines. That's what we're really looking at. And on the order lines, we have a quantity of 1 and we have the product. But the order date applies to the full order, not just the order lines. So I'm thinking we need to separate out and have an orders table. And if we do that, the customer orders table, now we can have a customer order ID. And we can start grouping these up. And so before I do that, I'm going to actually insert a customer order ID so you can see this. And I'm going to say this is order 1, those aren't dates. And then I'm going to call this order 2, and I'm going to call this order 3, I'm going to call it 4, 4. Okay. So now we can have customer orders, and we're going to have 1, 2, 3, 4, and then customer order date, and we're going to have 8, 9. Okay, so now we have an order date. So the question is, order total, is that at the line level or is that at the total order level, right? And that's at the order level. So now we have order total, and we would stick that at 70, and then order 2 total was 57. So now that we have a primary key here, we can drop order date here. And we can drop order date here. Okay, and so now this is a foreign key. Okay, and then just to kind of make this sit the way it should sit, just to make it look better so that all the foreign keys are in the front. With customer ID, you can't have 2 customers per order. There's going to be 1 customer per order. So we don't need the customer ID sitting on the lines. So what we need to do is bring it over here. So let me add some room. Now we're going to have customer ID. And let's go with, we have B Smith. So now this is a foreign key. And now on the lines we don't need it. So the orders hook up to the lines. We can actually get rid of this column. So now we're getting to the right grain of everything, and that's what we're trying to figure out is what level do we need to record everything. So on the customer order, so what you end up having is you have customer orders, and then in the customer orders you actually have the line items of the products they ordered and how many they ordered. Okay, but we don't actually store the product name in here, we store the product ID. In the product ID we can get to all the rest of the information about cost. Okay, so there is really nowhere else to go on this one. I mean, that's down to the bare minimum. Customer orders, is everything in the customer order at the same grain as the customer order ID? So the order has its own date, and it has its own order total, and it has the customer attached to it. So there's nowhere else to go on that one either. So then we need to come down to our other tables down here. So we have our customer order lines, we have our customer orders. Now what about our product table and our customer table? Well, the product table, let me expand this out just a little bit. I'm going to take these individually and I'm going to move them so we can look at each one individually. So I'm going to come down to an empty space. Let's look at products by themselves. So we already learned from our normalization earlier, from third normal form, this product manufacturer address references the product manufacturer, which then references the product. So there is a transitive dependence. So we need to pull the product address out to its own table. So then we no longer need this address. So let me get rid of that. So now the address is over here, and we have our own primary key. Now before I do that, I gotta spread this out some more so we can see what's going on. That we have multiples in here. So this primary key should be product manufacturer, but we have this one and this one and this one, and we'll delete those out. Okay, so now we have our product manufacturer table just like we did in our other exercise. If you remember, that was our third normal form where we pulled the product manufacturer out. Okay, so now the product manufacturer is out. Is there anything else in product? So we have a product ID, and now instead of the product name relates to the product ID, the manufacturer actually relates to the product ID, because in this case, Spalding and Titleist both have basketballs, right? So we have to get all the way to the product ID for it to make sense. So product relates to the ID, product manufacturer relates to ID, the details will relate to the ID, and then the cost will relate to the ID. Okay, so I think we've broken down the product as far as we can break it down. So now we've normalized it, and let me do this for a second. We'll make this one the product manufacturer, that's the primary key, and now this is a foreign key relationship. So finally, let me grab our customer table. So on the customer, we want this to be our primary key, but we've got so many rows right now, but we don't need it anymore. Not all of them. Let's see what's repeated here. So these rows are actually just repeated. So let's just get rid of those rows, because all we need is the one B Smith for the customer ID. Alright, so we're down to their one row. Jill Thomas, those are two exact rows, so let's get rid of those. And then BS Smith 2, two exact rows. Okay, so we really have three customers. We have two Bob Smiths, but they're two different people with two different IDs now. But now we've got to deal with our first normal form issues, which when I see two things stored in one column, that's automatically a problem to me. So we can easily insert and shift cells to the right and add our customer email. And now we have to get rid of the extra bit of information there. Okay, so now we've fixed the customer storing two different things in one column. I also want to fix the formatting here. And now we have this customer email subscriptions has two things, and then we've got these two categories here. So we know from our prior exercise on fourth normal form that we need to separate this out into two tables with a primary key and then a foreign key on email subscriptions. So in this case, we need to do it twice. We know we're going to have this part of the table by itself. This is our customer table. I'll drop that right here. But now we're going to have our customer email subscriptions as its own table. And so I need this one. I'll drop it here. And I need this one. And we need to break this row into two. So now we have B Smith, and then we have basketball, and then we have baseball. Okay, so now we've gotten rid of that non-atomic field. We've got to do the same thing with these two different columns. So let's do that. I'll grab those down, and then I'll grab this back, and we need a new row here. So B Smith, this also has a golf catalog, and then B Smith 2 also has a baseball catalog. And we only have one catalogs now. Get rid of that. And we now have it all normalized. So let me put the full picture together. Okay, so that is our model. We have customer order lines, we have customer orders, we have products and customer tables, we have the email subscriptions and the mail catalog split out, and then we also have the product manufacturer split from the products table. So we went through the first, second, third, and fourth normal forms. We actually took a pretty complex table and broke it down into multiple tables. We went from this table here all the way back to these tables broken down in normal forms. As always, if you like this video, please subscribe, please like the video down below, and connect with me if you have any questions on LinkedIn or Facebook page, or you can connect with me at SQLtrainingonline.com, and I'll talk to you next time.